Okay, so this is problem 3.5.31, and we're supposed to find all zeros, and this is the function that they're giving us. And so what we want to do when we're finding the zeros is we want to first of all make a PQ list. And P is going to be all of the factors of our constant term, and that's this right here, and Q is going to be all of the different factors of the coefficient of our highest power. Okay, so our Q list would be plus or minus 2 and plus or minus 1, and our P list would be plus or minus 10, plus or minus 5, plus or minus 2, and then plus or minus 1. Okay, so the P over Q list is going to be the list that, you have to excuse me because I have a little bit of a cold. The P over Q list is going to be the list that's going to contain our possible rational zeros. Okay, so if I take P and divide by Q, then I get 10 over 2, which would be 5, or 10 over 1, which is 10, 5 over 2, or 5 over 1, which is 5, and we already have that on our list, 2 over 2, which is 1, and 2 over 1, which is 2, and then 1 over 2, or 1 over 1, which we already have. Excuse me. Okay, so what we want to do now is we want to just pick, and we're just going to try, any of these numbers and use synthetic division into this function right here to see if we can get a zero. And so I'm going to start with, I actually did this ahead of time, otherwise this can take a lot of time to find these zeros. But 2 is one of the zeros, and we'll find that by, if we take a look at each of the coefficients here of our 2x to the 4th of our function, the 2, the negative 11, the 20, and so on. And if I take 2 and I do synthetic division into this, then it's bringing down my 2 here, and then I've got 2 times 2 is 4. Negative 11 plus the 4 is negative 7. Negative 7 times 2 is negative 14. This is 6. 6 times 2 is 12. Negative 7 plus 12 is 5, and 5 times 2 is 10. When I add these two, I get 0, and this 0 right here is what tells me that 2 is one of my zeros. Okay. Now, the question for the person that asked this over email, their question was, when they get to this point, then they're not able to find, the next zero. So let's actually look at the depressed equation here. The depressed equation at this point would be, P of x is equal to x minus 2, and the x minus 2 is this factor right here. But the depressed equation would be these coefficients, so 2x cubed minus 7x squared plus 6x plus 5. Okay. And really what we're doing is we're trying to now work with this and essentially find the zeros of that portion of this function. So when you go to find zeros of this, what you should notice here is that anything that's going to be a zero of this portion of the function will also be a zero of the overall function. So the PQ list for this particular portion is actually much smaller because of the fact that the P over here is 5, so we just have plus or minus 5 and plus or minus 1, whereas Q, plus or minus 1 and plus or minus 2. So the P over Q list for that particular portion of the function just becomes plus or minus 5, plus or minus 5 halves, and then plus or minus 1 and plus or minus 1 half. So the nice thing is you can eliminate some of the numbers that were up here and just focus on these. Okay. Alright, one of the things that you need to be aware of is that if, for instance, we also had 2 on this list, then you would want to try it again because it's a potential that you could end up having it as a repeated 0. Okay, but it's not on our list, and it turns out a negative 1/2 is going to be the number that will work. There. there, so pardon me, I've just come down with a cold today, so I'm really sniffling a lot at the moment, but okay, so if we try a negative 1/2, and we're just going to use this in the depression equation, the two, negative 7, 6, and 5, and then take a look at what we have. So bring down the 2. 2 times negative 1/2 is negative 1. Negative 7, negative 1, add, we get negative 8. Negative 8 times negative 1/2 is positive 4. Add, we get 10. And 10 times negative 1/2 is negative 5. And then we get a 0. Okay. So now what we're dealing with is this factorization. We have p of x is equal to x minus 2, that was a positive 2 as one of the zeros, x plus 1/2, and then the depressed equation here is 2x squared minus 8x plus 10, and that's coming from these values right here. Okay. Alright, so to solve for the rest of the zeros, we have, x equals 2, x equals negative 1/2. For the remaining zeros, we actually need to take this quadratic and set it equal to 0. And then solve. Okay, so you can either use the quadratic formula, or if it factors, we can factor it. This one looks like it factors at least with a common factor of a 2, so I'm going to start with that to just see if it will factor. So this is x squared minus 4x plus 5. And that looks like it's going to factor, but it actually doesn't, because if we tried it here, x and x, 5 and 1, we'd have to go like this in order to get the negative 4, but that would give us a negative here, and not a positive. Okay, so we're going to need to stick this into the quadratic formula, right? So we can actually just stick in the coefficients for this right here, because we could, this quadratic, because we could divide out the 2, essentially. Okay, so I'm going to go with this one. We have a equals 1, b equals negative 4, and c equals 5. And x is equal to the opposite of negative 4, I'm using the quadratic formula, plus or minus b squared minus 4 times a times c all over 2 times a. Okay, so this is 4, positive 4, plus or minus, this is 16 minus 20 all over 2. So this is 4 plus or minus the square root of negative 4 all over 2. And if we continue with solving that, so 4 plus or minus square root of negative 4 over 2, so square root of negative 4 is 2i, so this becomes 4 plus or minus 2i all over 2, which then simplifies if we divide 2 into each of these. This becomes 2 plus or minus i. Okay, so there's 2 of our roots. We found x was equal to a negative 1/2, and we found x is equal to 2. Okay, so to reiterate what your question was, when you go to find this second zero here, this x equals negative 1/2, you can work with the diminished PQ list, and you're just, again, just plugging these in using synthetic division until you find that 0. Okay.